Put a dot anywhere on the circle in each quadrant. It does not matter where. Now, what would this guy's coordinates be? Are there any numbers on this graph? No. So he must have what kind of x coordinate? Positive or negative? Positive. And what would his y coordinate be? Positive. Excellent. What about this red guy? What would he be? Negative x, positive y. What about this green guy? What would he be? Negative x, negative y. And what about this black one down here? X, negative y. Does everybody understand what I did there? Everybody's cool? All right. Now, we are pretending this is a perfect circle, yes? Which means this distance right here from the center of the circle to the edge of the circle is what mathematical word? Radius. Everybody cool? Everybody's cool? All right. What is that one? That's also R. Great. What is that one? Also R. Awesome. What is that one? Also R. Awesome. Does everybody understand every part of this circle that I have drawn? Everyone's cool? All right. So, if we draw a circle that centers on the origin, we can agree that the line from the origin out to the edge is always going to be the same, yes? Everyone is cool with that? All right. Now, have I given you something yet on which you can perform trigonometry? Yes or no? Jazz Carrot says no. Why can't we do trig right now, Jazz Carrot? Pardon me? I only have one line. What do I need to do trig? I need 3 sides. I need a triangle, don't I? Everybody cool? All right. Now, if we were doing trig in grade 10, what would the sine of theta be? How do we find the sine of theta? SOHCAHTOA, what would sine be? Opposite over hypotenuse, yes? What would cos be? Adjacent over hypotenuse. And what would tan be? Opposite over adjacent. We all know that already, don't we? Right? Now, please watch what happens. I am going to make this circle so you can do trig. Everybody ready? We're only going to do it once for now. What did I just make? A triangle. How far this way did I go? Can you tell me? X. I went X that way, didn't I? How far up did I go? Y. Everybody with me? Now, does that give me 2 sides of a triangle? Yes, it does. What is this? R, but what is it on the triangle? It is R, but it is also the hypotenuse, isn't it? Now, you guys are smart kids. This is my theta, yes? This colored in corner, agreed? Everyone agree? Okay. What is sine of blue theta? Y over H. Whatever that Y value is, It's the opposite, isn't it? Everyone agree? Okay, so what is cos of blue theta? X over h. And what is the tan of blue theta? Y over x. Does everyone see how that works? Everybody? Okay. Well, don't I have 4 triangles here? What is red sine? Y over h. What is red cos? Look closely. Negative x over h, isn't it? Because I went this way. What is red tan? Y over negative x. What is green sine? Oh, that should have been green. Son of a motherless. What is green sine? Negative. Negative y over h. What is green cos? Negative x over h. What is green tan? Which is y over x, isn't it? But we're going to write it as negative to keep the pattern going, but I'm going to remind you that that's positive. Everybody cool? And what is black sine? Negative y over h. X over h. Negative y over x. Now, all of you should notice something about the sine, the cos, and the tan in each of the quadrants. What did you notice about them all in the blue quadrant? They're all positive. So out here, sine, cos, and tan are all positive, aren't they? Why? Because x and y are positive. Everybody see that? Okay. What in the red quadrant? What's positive? Sine is positive. Cos is negative. And tan is negative. Why is that? Because x is negative and y is positive. Everybody cool? Everybody good? Okay, what's happening in the green quadrant? Look again.
Oh, all negative except for tan.
There you go. Sine is negative, cos is negative, and tan is positive because negative x and negative y. Everybody cool there? And finally, in the last quadrant, what's sine? Negative. What's cos? Positive. And what's tan? Negative, because x is positive and y is negative. Is everybody cool with that? Now that tells you something. That tells you that in this quadrant, cos is positive. In this quadrant, all are positive. In this quadrant, sines are positive. And in this quadrant, tans are positive, which sets up another thing like SOHCAHTOA. C-A-S-T. Cast. You don't need to remember it as long as you know the principle behind it. Is everybody cool with this? Now, some of you will have noticed that we used X and Y up here, didn't we? Right? And the CAST depended only on X and Y, didn't it? Right? I mean, X and Y are right there. How do we get the hypotenuse to do sine cos? Because we know that point right there is x, y. We know that that's x and that's y. So it's real easy to do tan. How do we get that number? Right. The hypotenuse is always the square root of x squared plus y squared. Which means the hypotenuse always has what value? X and Y can be what? What are my choices for X and Y? They can be one of two things. What? Positive or negative. What must the hypotenuse be? Why? Whenever you square something, you get a positive, don't you? So the hypotenuse is always a positive value. Is everybody good? Everyone's good? All right, that's the theory. Let's put it into practice a little bit. At the top of the next page, I'm going to ask you to write down, instead of SOHCAHTOA, we're going to write down sine, cos, and tan with the letters. What is sine? You just wrote it down 2 seconds ago. If you've got to flip back a page, that's cool. What is sine? Y over H. What is cos? X over H. What is tan? Y over X. X and Y are coordinates. Right? So what is that? It's an X and a Y, which means what is my sine? Well, I know sine is Y over H, right? So what's my Y? 0 divided by H. Do I need to even check for H here? No, because what's 0 divided by anything? So my sine of this would be 0. Agreed? What is my cos of this? X over H. What's my X? 4 over H. Uh-oh, I need to know H. Once I need to know H, what do I have to do? Once I need H, what do I have to do? Square X and Y. H is the square root of 4 squared plus 0 squared, right? What's 4 squared? 16. What's square root of 16? 4. So cos is what? 4 over 4. 1. What's tan? Tan is y over x. 0 over 4, which gives me 0. Is everybody cool? Do that 4 times. What is the h for b? H equals 3. So what is my sine, cos, and tan for b? Sine equals 1. 3 over 3. Cos, 0. Tan, 3 over 0. Are we allowed 0 on the bottom? So tan is undefined. What's C? What's the H? Five. So what's my sine? 0. What's my cos? -1. What's my tan? 0. And D. What's my H? 2. What's my sine? -1. What's my cos? 0. What's my tan? Undefined. Is everybody good with these 4 easy ones? Now, the question becomes, why are they easy? Because there's zeros involved, right? That first guy right there, the terminal arm was at 4, 0, correct? So that was an angle of 0, wasn't it? The next one was 0, 3. Up there. Easy, 90 degrees. Next one was -5, 0. Easy, 180. And then the next one was 0, -2. Easy, 270. All of them were 90s, right? Right? Okay. What happens here? What do I know? I have an x of what? -4. I have a y of what? And I know that h equals what? The square root of what? X squared plus y squared. What is x squared? 16. What is y squared? 121. So that must be the square root of 137. Agreed? Now, when I say exactly, do we break that down? Do we? No. So now I have a x, a y, and an h. Tell me the sine, the cos, and the tan of theta.
Sine
11 over root 137, because it's y over hypotenuse. What's the cos? -4 over root 137. What's the tan? 11 over -4. The sine is positive or negative? Positive. The cos is what? Negative. And the tan is what? Negative. So which quadrant must it live in? Can it live here? Why? Everything's positive there. Can it live here? Yeah, because this is where sine is positive. Draw it. What's the x? -4. What's the y? 11. How are you going to use that -4 and that 11 to find an angle? This goes back to grade 10 now, because what have I made right here? I've made a triangle, yes? How do you find angles when you know sides? It is shift. Which one can I shift? I could do shift tan, but could I also not do shift sine, shift cos, or shift tan? Why would you choose tan? Because there's no root. So everybody get out their calculator and tell me what shift tan is. We're going to use tan because there's no radical. So we are going to do shift tan of 11 divided by -4. And what are we going to get when you punch that into your calculator? You're going to get -70, yes? So the angle has to be 70, right? Now you guys are smart kids. Is that 70? No, because we went clockwise. It's positive, isn't it? Clockwise, counterclockwise is positive. So somewhere involving this terminal arm, I have to go clockwise 70 degrees. Where is it? Where's the only place that I can go clockwise and get 70? Right there, right? Everybody agree? You do shift tan of 11 divided by -4. Do you need to see it done? Shift tan 11 divided by -4. Close brackets, enter. -70. Everybody cool? All right. So there's only two angles associated with its terminal arm, yes? One of them went counterclockwise, so it's positive. -70 has to be here, doesn't it? If this in here is 70, I want theta. Where does theta live? Which is theta, the blue or the green? We just did it right here. Where's theta? Theta's on this side, right? So, where's theta? Blue or green? Green. If this is 70, then what's the green part? 110. So what's theta? 110. Now I need you guys to watch something. Shift. Tan 110. Everyone agree? Everyone see it? Everyone's cool with that, right? Now, what is 11 divided by -4? What's it going to be? It's going to be Negative 2.75, which is what we had right there. Does everybody see? The tangent was the same. Everybody good? All right, let's try the next one. My computer's frozen. You guys go ahead and get started. What? Probably. Of course I know how to change it. You go to mode and get degrees. Highlight degree, not radian.
Oh, yeah. Okay. See, we're on the right line. Thanks for showing us.
No prob. I forgot to remind you to make sure you were in degree. All right, here we go. Let's do this again. Sketch and determine the value of the angle whose terminal arm passes through this point. Where is 4, negative 3? Fourth quadrant. Out 4, down 3, right? So I need to make the triangle. 4, negative 3. Does everyone agree? Okay. Where is my triangle? It's right here, yes? What parts of the triangle do I know without doing any math? I know x and y. So should I use sine, cos, or tan? Tan. What is tan? Y over x. What is the y value here? Negative 3. What is the x value? 4. So now I know what the tan is. How do I then find the angle? Shift tan of negative 3/4 gets me what on my calculator? Everybody do that. Shift tan negative 3/4, which is of course negative 0.75. What do you get? Negative 36, right? We're going to round that to 37, yes? So is negative 37. What direction is negative? Clockwise, right? So if I start here, I go clockwise 37 degrees, yes? Is that a reference angle or is that theta? That's a reference angle. So I must need which side of it? This side of it. How much is it? And don't tell me the answer. Tell me how you're going to find the answer. 360 minus 37 to get 323 degrees. Is everybody cool? Please notice that we have now put together what we did yesterday, what we did today, and grade 10 trig. Is everybody good? If I am going too slowly, I apologize, but we're putting together a whole bunch of stuff right now. Turn the page over. You guys try 4. 4 is tricky. Read the question carefully. Oops. That's no good. I'm going to highlight some stuff that's important here. Quadrant 2. And that. I'll let you work for a moment. How many people feel they have no idea how to even start looking at this? Okay. How many people can see one or two things? How many people feel that they can work this all the way through? I haven't given you enough time. I'm just asking. All right. For those of you that have no idea how to start, I highlighted two things, didn't I? What did I highlight? Quadrant 2. So where must this line go? In quadrant 2, which is where? Somewhere out here, yes? Excellent. What do you know about tan? It's y over x. Now, if I'm going out here, which one of those is negative? The x. So this must be negative 5, and this must be 9. Agreed? Okay. So now I am looking for an angle. Is that tan or shift tan? Shift tan. So I must go shift tan of 9 divided by negative 5. Correct? And what does that give me on my calculator? I'm going to go to my calculator. Shift tan 9 divided by negative 5. And what do I get? Negative 61 degrees. Yes? Now, I know that in this triangle, I must be finding this corner, right? Because I have opposite and adjacent. And since I know it's negative, I must be going clockwise from the edge, yes? So when my machine wakes up, this must be 61 degrees. Is that a reference angle or is that a theta? That's a reference angle. So I must need to find theta. How? 180 minus 61, which is 119. And then I say to myself, self, I better make sure. Is 119 going to have a negative tan? Yes or no? Yes, because of what we did at the very beginning here. Tans are negative up there. So we know we're right. Is everybody cool? Now, we're going to do a little bit of calculator work here just to prove some points to you guys. Use your calculator and tell me all 8 of these values. Go. You just got to punch it in. Sine 43 equals. Cos 170 equals. Just tell me what they all are. You needn't go to 4 decimal places. I'd be perfectly happy with 3. It doesn't really matter. But when you got all 8, we're going to talk about it. All right, who's got some values for me? What's A? Okay, so 0.682. It'll show up eventually, I hope. What's B? 0.985. What's C? 0.985. Was D 0.176. Now there's one number there that's wrong. B. What's B really? Negative. Did you say negative? Okay, I didn't hear you. And EFGH. What's E? Negative 0.682. F. Negative 0.682. Wait a minute. G. Error, which means it's undefined. And H. 0.1763. Now, let's answer some questions about these. What has exactly the same answer? E and F. And? E and F. And D and H, correct? Everyone agree? Okay. I should use a different color for D and F. Or D and H. Let's make them red. So, the reason that is, you guys already know, I think, in your heads, where would E be on this? Where would 223 be? Down here, yeah? Everyone agree? And where would F be? Quadrant 4. There's E, there's F, yeah? What is this part of E? Just the reference angle. What would it be? What would it be? The whole thing is 223. What's the reference angle? 43. What about F? What's F? 43. That seems odd. Let's do D and H. Where would D be? Quadrant 1. 10 degrees. Where's E? H? Quadrant 3. The red line will show up in a minute. What's the reference angle? 10. What do you notice? They're the same. Everybody cool? What do you notice about the two that are the same numbers but negative values? What are they? B and C. B and C. And A, E, and F, right? We already talked about E and F being the same, so I'm only going to use A and E. Everybody cool? And I should have used green, different color. Why is that? Go back to our quadrants. Where is B? Cos of 170. Where would that be? Right there, right? This is 10. This is 170. Where is C? Quadrant 4, down here, right? What's this? 10. What's this? 350. Please notice, when we are doing sine, cos, and tan with our calculator, what is it usually giving us? We'll do the green one too. A is where? 43. E is where? Down here, 43. So what is our calculator in all of these examples giving us when we push sine 223? Is it giving us the sine of 223? Or is it giving us the sine of the reference angle? It's giving us the reference angle, isn't it? How do we know where it goes? Cast. If it's negative, it must be down in here for sine. Everybody cool? Now, Sometimes your calculator isn't going to do that for you. And that is when you have to know what is happening. Everybody understand? Your calculator can think between 0 and 180. Okay? It doesn't do well down here. So sometimes your calculator is going to give you a theta. You got to know when. And how do you know when? CAST. And we're going to talk about that right now when we do 6 and 7. Turn the page over. 2 more questions, then I'm shutting up and letting you go on your own. What is sine? Opposite over hypotenuse, but we're no longer using just triangles. We're on the coordinate grid. So what should it be? What should sine be? Y over h. Excellent. Now, if sine is negative, where are the places it can live? Can it be up here? No. Can it be here? No. So it must be here or here, correct? 5 must be the h. So where does 5 go? On the hypotenuse. The -2 must be here. Everyone agree? Everyone agree? Okay. So how do I use my calculator to find theta? Is it a shift sign or a sine? So I must have to do shift sine of what value? -2 divided by 5. So what is it? When I do that with my calculator, what does my calculator give me? It's going to be weird. What does it give me? So -24, yeah? Now this is a precise example of when you have to know what is going on, because the general rule doesn't necessarily apply, yeah? If this is giving me 24, where in this diagram is 24? It is the what? No. It's the reference angle, right? Where are the 2 reference angles? (24) and 24, yeah? Okay. So if this is 24, how big is red theta? (204). How big is blue theta? (336). Can you give me a single value of theta in this question? Yes or no? No, you can't, because both of those will return that sign. What would I need to add to this question so you could give me a definitive answer? Cool. Telling you what quadrant. Everybody understand? If I said in quadrant 2, what's the answer? I'm trying to trick you. What is the answer if I said quadrant 2? There isn't one. Okay, good. What is the answer in quadrant 3? 204. What is the answer if I ask you in quadrant 4? 336. Is everybody cool? Everyone is good? All right, you guys try 7. It's tricky. What makes it tricky? There's a root involved, isn't there? I'll let you work for a second. I'm only going to give you one hint. Cos is x over h. And which of those is the only thing that's allowed to be negative? X or h? Hypotenuse can be negative. Only the x can be negative. So where is that? Is that an x value or an h value? And I'm going to wait a moment while you work on it. If you finish it, feel free to go ahead and have a look at the next few pages. It looks like a lot, so what I'm going to do is I'm going to go ahead and highlight the bare minimum that you should do if you wish to actually get this. I'm going to start doing that now, then I'm going to come back and finish number 7. And all of this will be recorded. Okay, guys. Anything highlighted green, you should do all of that question. Anything highlighted blue, you only need to do a couple. And it's all on the recording. Now, let us go back, cabbages, and actually talk about this one. If the numerator has to be the negative, I must be somewhere out here, yes? Wake up. Please just work. This must be negative root 3, correct? Which means, what is this? Positive 2, right? Everyone cool? Sorry, yeah, it's the hypotenuse, 2. Which means I could also be down here. Everyone cool with that? So now, since I have my values, what am I going to use? I'm going to shift cos this, aren't I? How do I do that? Negative root 3 divided by 2, right? Everybody's got a different calculator. I'm not going over how to do that. You're in the 11th grade. You should know how a calculator works. And when you get that shift cos, you're going to get a value. What is it going to give you? Now, this is what I was talking about. Your calculator can think between 0 and 180. So this gave me 150, right? Does it make sense that that's a reference angle? No. So it gave me one of my thetas, right? But it also could have given me this. But my calculator doesn't think well past 180. So if this is 150, what does that make this? 30. So what does that make this? 30. So what does that make blue theta? 210 degrees. Is everybody cool with that? Okay? 90% of the time, actually I don't even want to put a percent on it. Most of the time, your calculator is going to return to you a reference angle. But sometimes it isn't. You need to know what the thing looks like so you know what you are getting. Understand? Everybody cool? That's why I saved this example for last. So you can see that sometimes your calculator will give you theta. But not, I know it will, Nick Dietzel. He doesn't actually know that. But, everybody good? All right, now, again, on your work, if I've highlighted it in blue, you really only need to do a couple. But if I highlighted it in green, you should do all of that. Okay? So if you want to change that around, I'll shrink it down a little so you can see more of it. There's the whole first page, 96. The blue stuff is just do a couple of them. If it goes A, B, C, D, you only want to do A and D, that's fine. That should be enough. Can I go to the next page? This is all being recorded anyway, so you can always check it later. There on 158, you should do 11, 12, 14, and 15. And remember, I haven't given you the answers. Just try them. And on the last page, try a couple of the extends, 22 or 23. I don't care which one. Now listen to me. If you want, to guarantee the A, try all of them or some of all of them. All right? You have all the material you need in front of you to get whatever grade you wish to get. The more you practice, the better you're going to do. Now, I know I haven't given you the answers. That's okay. Right? Just try them. Tomorrow, you can ask me about them. Okay?